In this video, I want to have a look at problems involving sine and cos and how we can rewrite them into different forms. So the reason we're going to rewrite them into this different form is that it often makes solving trig equations or graphing trig functions a little bit easier. So we're going to jump straight into an example. It asks us to write root 3 sine x plus cos x in the form r sine x plus alpha. So the first thing I'm going to do is put those two things equal to each other, and then we're going to go through and we're going to find the values of r and alpha. So we start off by rewriting them and putting them equal to each other. We're going to have root 3 sine x plus cos x is equal to r sine x plus alpha. Now on this side, I'm going to go through and expand this out using our angle sum result. So we're going to have r outside of sine x cos alpha plus cos x sine alpha. Now, if I expand this out, I'm also going to rearrange these terms so that I've got the cos alpha coefficient at the front and the sine alpha coefficient at the front of there as well. So I'm going to have r cos alpha sine x plus r sine alpha cos x. And now I can equate coefficients on both sides of that equation. So here I've got my sine x term and its coefficient is the square root of 3. And here is my sine x term on the right hand side and its coefficient is that r cos alpha. The coefficient of cos x here is just 1 and the coefficient of cos x on this side is my r sine alpha. So if I equate those, I'm going to have the square root of 3 equals r cos alpha and I've got 1 equals r sine alpha. So now I have two equations and I have two unknowns, my r and my alpha. So I'm going to call them equations 1 and equation 2, and we're going to solve these simultaneously. Now the way we're going to do it is we're going to add 1 squared plus 2 squared. So 1 squared plus 2 squared. So this side squared would give me 3. So the square root of 3 squared is 3, plus my 1 squared, which is just 1, is going to be equal to this squared plus this squared. So we're going to have r squared cos squared alpha plus r squared sine squared alpha. Now this side's just going to give us 4. If I factorize out my r squared here, I'd have cos squared alpha plus sine squared alpha. Now we know that cos squared plus sine squared is just 1. That's one of our trig identities. So we're going to have 4 equals r squared, and that will just give us r equals 2. Now, why not plus or minus 2? We're always, when we read it out in this form, we're always going to have r as a positive number. All right, so that gives us one of our unknowns. That tells us what r is. I'm going to come up here for a second. I'm going to sub r equals 2 into either equation 1 or 2. It doesn't matter which one. If we substitute it into equation 1, that's going to tell me that 2 cos alpha is equal to the square root of 3. So substituting that 2 back in here, which means that cos alpha is root 3 over 2, which means that alpha, this is one of our special angle results, exact values. So our alpha is going to equal 30 degrees. So that means we can rewrite this expression here as 2 sine x plus 30 degrees. Our second example is going to be a really similar process, except this time we've got cos instead. So our question asks us to write 3 cos x minus 4 sine x in the form r cos x plus alpha. So again, we're going to write it out as they're equal to each other. So 3 cos x minus 4 sine x is equal to r cos x plus alpha. Now we're going to go through same first step of expanding that out. Our cos expansion, we're going to have cos x cos alpha minus sine x sine alpha. And expanding that out and rearranging it a little bit, we'd have r cos alpha cos x minus r sine alpha sine x. Now again, equating coefficients, our coefficient of cos x is 3, and over here it's r cos alpha. And our coefficient of sine is 4, and over here it's r sine alpha. Now just be careful with your pluses and minuses, because it's a minus 4 and a minus r sine alpha, I can just ignore my negatives. So we're going to have 3 equals r cos alpha and 4 equals r sine alpha. So again, we're going to call those equations 1 and equation 2, and we're going to do the same thing to solve them simultaneously. We're going to have 1 squared plus 2 squared. So 3 squared is 9, plus 4 squared, which is 16, is going to be equal to r squared cos squared alpha, so this bit squared, plus this bit squared, r squared sine squared alpha. So this would give us 25 equals r squared outside of cos squared alpha plus sine squared alpha. Again, we know cos squared plus sine squared is 1, so that's just going to give us r squared is 25. So that means that r is going to be 5 because we're only looking at the positive case. So if we know that r is 5, we're going to sub r equals 5 into either equation 1 or 2. Again, it doesn't matter. So we're going to have 5 cos alpha equals 3, which means that cos alpha equals 3 over 5. Now this isn't one of our exact values, so we're going to have to find alpha by going cos inverse of 3 over 5, which is going to give us about, to the nearest degree, 53 degrees and 8 minutes to the nearest minute. So that means that we can rewrite this expression here as 5 cos x plus 53 degrees and 8 minutes. Now, there are some formulas for rearranging and transforming these sorts of questions, and these formulas, your textbook gives them to you, but your formula sheet doesn't. So you can use these formulas that I'm about to show you, but then just one more thing to remember. So the process that we just went through, that will always work for any of these types of questions. So it's something that you can always use rather than having to remember these formulas. So what they look like is if an expression looks like one of these on the left-hand side here, it can be rewritten into the form on the right-hand side, and we can use that r equals the square root of a squared plus b squared, and tan alpha is b over a. So that's two ways you can, or a formula that you can use to find the values of your r and your alpha rather than going through the process that we just did. But again, if you use these, they're not on your formula sheet, so there's something that you have to remember how to do.